Hello everyone, my name is A.Bhushan from B.Pharmacy first year in Maharajah College of Pharmacy is going to give a seminar on gluconeogenesis. What is gluconeogenesis? It is the process by which glucose molecules are produced from non-carbohydrate precursors. The major precursors for the processes are glycerol, amino acids, and pyruvate pathway. Glucose is converted to glucose 6-phosphate by the enzyme hexokinase or glucokinase by the conversion of ATP to ADP, and one pyrophosphate molecule is released. Glucose 6 then this reaction can be reversed. Glucose 6 phosphate is converted to glucose by the enzyme glucose 6 phosphatase, and one H2O molecule is utilized. Glucose 6 phosphate is converted to fructose 6 phosphate, and fructose 6 phosphate is converted to fructose 1,6 bisphosphate by the enzyme phosphofructokinase, by the conversion of ATP to ADP, and one pyrophosphate molecule is released. This reaction can be reversed. Fructose 1,6 bisphosphate is converted to fructose 6 phosphate by the enzyme fructose 1,6 bisphosphatase, and one H2O molecule is utilized. Fructose 1,6 bisphosphate is a hexose. Then this gives the two trioses, glycerol 3 phosphate and dihydroxysteroid phosphate. Glycerol is converted to glycerol 3 phosphate by the glycerol kinase, by the conversion of ATP to ADP. Glycerol 3 phosphate is converted to dihydroxysteroid phosphate by the enzyme glycerol 3 phosphate dehydrogenase by the conversion of NAD to NADH2. Then glycerol 3 phosphate is interconverts to dihydroxysteroid phosphate. Glycerol 3 phosphate is converted to 1,3 bisphosphoglycerate by the conversion of NAD plus to NADH2. 1,3 bisphosphoglycerate is converted to 1,3 phosphoglycerate. 3 phosphoglycerate is converts to 2 phosphoglycerate. 2 phosphoglycerate is converts to phosphoenol pyruvate. Phosphoenol pyruvate is converted to pyruvate by the enzyme pyruvate kinase by the conversion of ADP to ATP. Pyruvate is converted to lactate in cytosol by the conversion of NAD plus to NADH2. In cytosol, from the cytosol, the pyruvate is converted to pyruvate is enters into mitochondria. In mitochondria, pyruvate is converted to oxaloacetate by the enzyme pyruvate carboxylase by the conversion of ADP plus Pi to ATP, and CO2 is released. Oxaloacetate is converted to alpha ketoglutarate. Alpha ketoglutarate is converted to succinyl CoA. Succinyl CoA is converts to fumarate. Fumarate is converts to malate. Malate is converts to oxaloacetate by the enzyme malate dehydrogenase by the conversion of NAD plus to NADH2. Oxaloacetate is converts to phosphoenol pyruvate by the enzyme phosphoenol pyruvate carboxykinase by the conversion of GTP to GDP, and CO2 is released. Phosphoenol pyruvate is converts to pyruvate by the enzyme pyruvate kinase, and by the conversion of ADP to ATP. This is the pathway of gluconeogenesis. Alanine Cori cycle and alanine cycle. Jetty Cori is discovered the Cori cycle. Glucose in liver is passing through the blood into the muscle. Glucose is converts into pyruvate in muscle. Pyruvate is converts to lactate. From muscle to liver, the lactate is passing through the blood. In liver, the lactate is converts to pyruvate. Pyruvate is converts to glucose. This is the Cori cycle. And alanine cycle, glucose is passing through the blood into the muscle. This glucose is converts to pyruvate. Pyruvate is converts to alanine. Alanine from muscle to liver, alanine is passing through the blood. In the liver, alanine is converts to pyruvate. This is the alanine cycle. Regulation of gluconeogenesis. The enzymes of gluconeogenesis are subjected to allosteric regulation and hormonal regulation. Pyruvate carboxylase and fructose 1,6 bisphosphatase regulate gluconeogenesis allosterically. Whereas all the key enzymes of gluconeogenesis are under hormonal control. First one, hormonal regulation. Insulin decreases the synthesis of key enzymes of gluconeogenesis. thus inhibiting gluconeogenesis. Various glucagon and glucocorticoid favors the gluconeogenesis. Second one, allosteric regulation. Pyruvate carboxylase is an allosteric enzyme. Acetyl CoA is its activator. Supply of glucose and fatty acid oxidation generates acetyl CoA. This in turn activates the gluconeogenesis. Fructose 1,6-bisphosphatase is another allosteric enzyme. Significance of gluconeogenesis. The major metabolic significance of gluconeogenesis is the maintenance of blood glucose levels, especially in starvation. The glycogen storage gets depleted in 12 to 18 of prolonged starvation. This process enhances lipolysis and protein catabolism so that blood glucose level is maintained to normal. Conclusion. Gluconeogenesis is occurs in the mitochondria and cytoplasm. It is an endorganic reaction where 6 ATPs are utilized per one glucose molecule. The raw materials of gluconeogenesis is lactate amino acids like alanine and glycerol. The gluconeogenesis net reaction is 2 pyruvate plus 4 ATP plus 6 2-GTP plus 2 NADH plus 2H plus 6H2O gives rise to glucose plus 4 ADP plus 2 GDP plus 2 NAD plus 6 PI. Thank you.